Now let's take a look at the last topic in this section. It's called nth term diverges test. Okay, so firstly, I'm going to give you the theorem. If the series an converges, then the last term or general term an has to go to 0, or limit n goes to infinity, an, the limit is 0. So this is easy to prove because we can say if the series converges, then the partial sum has to have a limit, goes to a certain number as a limit, right? And here as n, we can write down a1 plus a2 an. And then what is as n minus 1? That is n minus 1 term partial sum. N minus 1 till n minus 1. Now we use Sn minus Sn minus 1. So let's see. Sn minus Sn minus 1, which is an. Is that right? Or we can write down an on the left side. So an equals Sn minus Sn minus 1. And then this goes to, when n goes to infinity, you can see L minus L. So when n goes to infinity, as n goes to L, as n minus 1 also goes to L. So the limit is 0. That means if the series converges, an goes to 0. Next, we can get a contrapositive solution of our theorem 1. It's called, okay, how we get this one? We can take a look at contrapositive. Of a statement means what? Means if P then Q, then the contrapositive means if not Q, then not P, right? So here we have two statements. If P, then Q. The second, which is a contrapositive of the first one, if not Q, then not P. So let's see. If the limit of an is not 0, okay, fail to exist, or is different from 0, then not Q. That means not Q means the series is not convergence. Then we say series diverges. Okay, this is called the nth term test for divergence. We use this theorem a lot. Okay. Actually, the second theorem is more important than the first one. Let's take a look at the example. The first one, n squared n from 1 to infinity. The second one, n plus 1 over n. Now we want to see if those series converges or diverges. Let's take a look at the first one. An equals n squared. And what's the limit of an? Infinity. Because this does not go to 0, so we say the series diverges. It's very easy to tell, right? How about the second one? an equals n plus 1 over n. If we simplify, or you don't have to simplify, we know the limit. You can tell the limit from here, right? An goes to what? An goes to 1. It's not 0, different from 0. So by using the diverges test, we say this series also diverges. The last one, an equals -1 to the n plus 1. You can see an change from -1 to 1, bounce back and forth from between -1 and 1. So an, the limit does not exist. Same thing. An fail to exist. So we say an series diverges. Okay, this is called nth term divergence test. Now you can take a look at this exercise. N from 1 to infinity, -n over 2n plus 5. Second one, two problems. You can try those two problems by yourself. Now I'm going to give you the solution for those two. When I take a look at an, the first one, n over 2n plus 5, the limit goes to 1/2 when n goes to infinity, and this is different from 0, so we say this series diverges. The second one, I know the an goes to, you can simplify this into n squared plus n over n squared plus 5n plus 6 after we simplify, and you can see the limit is 1, right? And then it's also different from 0, so we say the series diverges. Okay, so usually when we tell the series converges, diverges, we usually like to look at an and look at the limit of the an firstly and see if it converges or diverges. If it converges, and then we find the sum. Otherwise, we don't need to do anything, just say diverges. That's all. Okay, we can stop here. That's all we need to know for this section. Let's see, I'm going to give you a summary for this series section. So the summary for this section, we learned the definition for an. This is called series. And then we know when it diverges, when it is converges, and when the Sn goes to a number, we say this converges, and the sum of the series is just the limit, right? And the second thing we learned is geometric series and the telescoping series. Geometric series, the sum is a over 1 minus r when r absolute value less than 1.